Okay, so we're going to look at rationalising surds. What that means is we're actually rationalising the denominator. We don't want a square root on the bottom. We want, just like we don't like negative powers on the bottom, we want to rationalise it so that square root isn't present. And to do that, we have a funny technique. So let's say we've got 1 over the square root of 6. Now, what can we multiply anything by that doesn't change something? Yeah, 1. So we can have a fraction that's equal to 1 and it will help us out. So this 1 over the square root of 6, if we rationalise it, we can multiply it by the square root of 6 over the square root of 6. That's 1. All right? And what we're actually going to end up doing here is getting rid of that square root from the bottom, because we've got 1 times the square root of 6, which is the square root of 6, and the square root of 6 times the square root of 6 is 6. Now we don't have a square root on the bottom. They're exactly the same thing, but this one's been rationalised, so we've actually helped out the denominator. And that's quite fun. But of course, we've got another problem here, in that we could have 3 minus the square root of let's just do a 3 over first. 3 over 2 minus the square root of 3. All right? We want to rationalise that bottom bit. It means we've got to get rid of the square root of 3. Now, the trick here is that we've got something called the conjugate. It means that we change the sign here. So we multiply by 2 plus the square root of 3 over 2 plus the square root of 3. Again, that's 1. When we multiply this, we get 3 lots of 2 plus the square root of 3, and something that's very similar to a quadratic. It's where our quadratic multiplying out skills come into play. So the top of this is 6 plus 3 lots of the square root of 3. Now we're allowed the square root on the top. Down the bottom, what we've got is 2 times 2 is 4. 2 times this is plus 2 root 3. 2 times this is minus 2 root 3, and negative root 3 plus root times plus root 3 is negative 3. So this particular technique means that we get a plus this and a minus this, and they cancel out, leaving us with 6 plus 3 root 3. Again, the root 3 is allowed to be on the top, over 4 take away 3 is 1. So in effect, this thing here rationalised equals this. It's got no roots on the bottom, so it's good to go. Now we can go one step further and we can actually end up having something that looks like this. Right? And again, we want to use this conjugate. Now it's the conjugate of the bottom, not of the top. The top doesn't change. So this equals 4 minus root 6 times 2 minus root 3 over 2 plus root 3. So that's our ordinary thing that we've got in our question. And this is our 1. That hasn't changed anything at all, except it does change it. We need the bottom to not have a square root. So the top becomes 8 minus 4 root 3 minus 2 root 6 minus square root of 18. The bottom becomes 2 times 2 is 4 minus 2 root 3 plus 2 root 3 minus 3. So tidying it up, we're going to have 3 things on the top and they're all going to have square roots, and that's absolutely fine. We've got 8 minus the 4 root 3 minus 2 root 6. We want to simplify this because it's 9 times 2. Square root of 9 is 3, so that's going to be minus 3 root 2. None of these are the same, so we can't put them together. And down the bottom, we've got rid of those ones, so we've got 4 minus 3 is 1 again. So the top line there is our answer. Okay? So you're going to do some work on that now, rationalising surds.